Okay, so let's take a look at problem 51 and kind of see how we could use our conditional probability. So what we have is we have 6 red balls and 4 green balls in the first urn, and in the second urn we have 7 red and 3 green. What we're going to do is pick randomly one of these balls and put it into this urn, mix it up, take a random one and put it into this urn. So we want to find the probability that we select a red ball from the first box and a red ball selected from the second box. So for part A, because we want, I have 6/10 chance of picking out a red ball first. So this would be the probability of red 1, let's say. But then when I put this ball over here, now I have 8 reds out of 3 green, or out of 8 total, out of 11 total. So I would have 8/11ths chance of putting it back. So this would be the probability of red 2 given red 1. And this is the probability that I get both of them being red on both sides, so I end up at the same part. So I get 48 out of 110, which is 0.436. Now let's talk about part B. Part B asks if at the conclusion of the selection process, what's the probability the number of red balls in the first box are identical to the second. First box are identical to the numbers at the beginning. What we want is they're either going to both be red plus the probability that I pick both green balls. So this would be 6/10 out of 8/11ths. Now for the green, I have 4 out of 10 chances. I move a green ball over here. Now I have 4 out of 11, and I could add those two together to get 64 out of 110 and get 0.581 for my probability then. Okay, so my final problem, let's look at number 59 about a gas station. And I'm going to do this 2 ways. One is using a table method, and one of these is using a tree method. So here I've got 3 gas stations, or 3 kinds of gas, regular, plus, and premium. And of those using regular gas, only 30% filled their tank, event B. And it says all the other ones, premium 50%, 60% for the plus. So I'm going to set up, let's do the table first. So in the table way, I'm going to have B, those that fill the tank, and those that don't fill the tank. And going across, I'm going to have A1, those who use regular, those who use plus, and those who use premium. I know that the probability of A1 is 40 because 40% use regular. I know that 35% use plus, and I know that 25% use premium. Whatever these two numbers are, they're going to have to add up to 0.4. Whatever these two numbers, they're going to have to up to 0.35, and whatever these two numbers, they're going to have to add up to 0.25. These numbers do add up to 1, and whatever these total numbers also have to add up to 1. So let's first of all take a look at this one right here, this hole right there. What I want to know is the probability of A1 intersect B. Well, I know what the probability of A is, and all I need to do is figure out what's the probability of B given A. Well, the probability of A, A1, get my ones there, my probability of A1 is 0.4, and then I know that those who use regular gas actually I don't know this one. So this is kind of what I need to find out. Well, let me try the other way. Here I then have the probability no, actually I do know those. Alright, so those using regular gas. So I know that this is 0.4 because that's the probability of A1. And then from the problem, I know that those who use regular gas, 30% of them fill it up, and so I get 12%. Let's try probability of A2 intersect B. Here I know what the probability of A2 is, times the probability of B given A2. Well, probability of A2 is 0.35. Now, knowing that someone uses plus gas, the probability that they're going to fill it up, the problem tells me that that's 60%. And so if I multiply those together, I get 0.21. And finally, for the probability of those people who waste their money using premium gas, I'm going to take the probability of A3 times the probability of B given A3. I know that's 0.25, and the problem tells me that 50% fill their tanks. Notice that 0.3, 0.6, and 0.5 don't all add up to 1. That's because they're percentages of these other ones. And so what I get is 0.125. Now, once I have this, I can fill in the rest of the chart. Well, if this is going to have to be 40%, whatever this is, it's going to have to add to that to be 40, and that's 28%. This to this, it's going to have to be 14%, and this to this has to be 12.5%. I can then add these across to figure out what the probability of B is, and if I do that, I get 455, and if I add these across, I get 545. And notice if I add these two together, I get 1. So once I have this chart, I'm already able to answer the questions because the chart is going to be easy for me to read. So just as a reminder, this is A1 intersect B, this is A2 intersect B, this is A2 intersect B complement. So these all in here are all intersections. So question A then asks, what's the probability the next customer will request plus gas and fill the tank? So what's the probability of A2 intersect B? Well, I go to A2, B, and I get 0.21. Let's go to question B then, which is a little trickier. What is the probability the next customer fills their tank? Well, filling the tank is the probability of B. And so the probability of B is, again, we've already done this in our heads, but let's go ahead and write it out. So 45.5% for part B. Now let's try part C from 59. If the next customer fills their tank, what is the probability that regular gas is requested, plus or premium? So we have three questions here. So we're given that the customer fills the gas. What we want to know is what's the probability of A2 given B and the probability of A3 given B. So given that they fill the task, what's the probability that they were either in regular, plus, or premium? So the probability of B here is 0.45. And the probability of A1 intersect B is 0.12. So this probability is 26.4%. Again, the probability of B is 0.455. Probability of A2 is 0.21. And I believe that is 0.462. And then finally, probability of A3 will be 0.455. We restricted it to this row. All these three numbers have to add up to this. So you're kind of finding the proportion of A3 over the total. This would be 0.125. And when I calculated, I got 0.274. Now notice that if you add up these three numbers, these will add up to 1. Okay, that's something to notice. In this case, they'll add up to 1 for this proportion. So given B, we're in the smaller sample size, and we can add up the three probabilities within this space. Okay. Now let's try it the other way with the with the treeway. And just to kind of set us up, let's suppose that I have C and D. I could do C and C complement, and from there I could have C intersect D, D, or C intersect D complement, C complement intersect D, and C complement intersect D complement. That's if we just had two. And so what that would tell me is the probability of C intersect D is equal to the first one. Well, what's the probability I get a C? And then given that I got a C, what's the probability that I'll get D? Okay, that's kind of our setup for the chair or the tree method. And let's kind of write this out. We know that we have the customers using the regular, the plus, and the premium. So what I'm going to do is I'm going to make 3 limbs or 3 branches. This first one is 0.41. That's the probability of A1. Probability of A2 will be 0.35. And the probability of A3 is equal to 0.25. So now we need to figure out the rest of the probability, and this would be 0.3. To put those together, we get the probability of A1 intersect B will be equal to the probability of A1 times the probability of B given A1, and so that's equal to 0.4 times 0.3, which gives me 0.12. The complement then, if we go down here to B complement, this will be 0.4 times 0.7, or 0.28. And here, to find the probability of A2 intersect B, first of all, we've got this branch of probability of A2, and then we need to find the probability that given A2, what's the probability of B? So we've got 0.35, and then given B, given A2 is 0.6, and when we multiply those together, we get 0.21. And then for this probability, again, we've got a 0.5 chance to go this way for B, 0.5 chance for going to B complement. We'd have 0.25 times 0.5, which would be 0.125. So answering those same questions, what is the probability of the next customer where we request plus gas and fill the tank? Well, we go A2, fill the tank, and so for the first question, we would have the probability of A2 intersect B, go down the branch A2, and then B would be 0.21. The second question is, what's the probability the next customer fills the tank? Well, I need to find out all the probabilities of where we ended up with a B. Here we got a B, here we got a B, B, I, B, I, L, E. That's the book for me kind of thing. So we could add up these 3 probabilities, 0.12 plus 2.1 plus 0.125. And again, what we get is 0.455. And then finally for C, it's asking us if the next customer fills the tank, what's the probability that regular gas is being collected, and the other ones. And so really we have to figure out the total probability. Again, we always look at the upper branches because those are the ones that give us all the B's. And then we need to figure out where we got on this branch. So this one was 0.12 over 0.5. This one we went up on this branch, we get 0.21 over 0.455. And then the last one, we go down this branch and we get 0.125 over 0.55. And we get the same answers as we got before. And just as a reminder, these should all sum to 1. So just remember, this all follows from this idea that the probability of A intersect B is equal to the probability of A times the probability given A that I get B. Or if you wanted to find it this way, the probability of B given A is restricting yourself to the probability of A and doing the probability of A intersect B. So I hope that helps.